Hi, all, I'm Greeshma. Currently, I'm doing my Masters in Geoinformatics at National Institute of Technology, Karnataka, India. Today, I'll be sharing a small piece of work done along with Sumina under the guidance of Dr. Kumar Sarangi, Scientist SG at Space Application Center, Ahmedabad. So, our work entitled Monitoring Phytoplankton Bloom Occurrence and its Associated Parameters in the North Eastern Arabian Sea using GHRSST data. So before getting into work details, let me give you a brief introduction. As we are aware now, Arabian Sea is one of the world's most productive ocean regions because of the circulation driven by the monsoons, that is southwest monsoon and northeast monsoon. So from the studies of the last decade, there have been tremendous changes in the spatial distribution of these phytoplankton. And often we use chlorophyll concentration as a proxy for phytoplankton biomass. And if we can connect the oceanic phenomena like upwelling, we can use SST for that is surface temperature. But mostly in data sets like MODIS and MODIS SST, there has been missing data, missing pixels or samplings or gap in data sets. So in order to cover all these, the best option is GHRST data. So there are different levels of GHRST data, out of which we use level 4 gridded and gap-free SST data. These were the main objectives of our study. First, to monitor the occurrence of algal bloom along the northeastern Arabian Sea for 5 years from 2018 to 22, and to analyze the oceanic conditions that may trigger the algal bloom through parameters such as sea surface temperature, chlorophyll air concentration, sea level anomaly, wind speed, and photosynthetically available radiation. This was our study area, that is Northeastern Arabian Sea of coordinates 90° north to 23° north and 62° east to 67° east. So why this particular coordinates is like we have taken it from Algorithm Information Service of INCOI's website. So which has identified 4 regions as hotspot, out of which one was Northeastern Arabian Sea. So first, for analyzing chlorophyll concentration, which is used for measuring the phytoplankton biomass, we used global data from CMEMS website and spatial resolution is 44 km. We use monthly data for the analysis, and with chlorophyll it also has data variables like PFTs and PSCs, that is phytoplankton functional type and functional phytoplankton size classes. We also used Oscar ocean current data for overlay over this chlorophyll plots. So it was taken from NASA's Spotlight website, and its spatial resolution is like 1/3 with wider resolution. So these are the chlorophyll monthly analysis plot for 5 years. And the presence of algal bloom was much better. We understood over the chlorophyll range of 0.01 to 5 mg per meter cube. And if we observe throughout the 5 year, we can see that during the months of February and March, chlorophyll patches of the algal bloom is observed more. And also for the southwest monsoon period, also we can see the chlorophyll patches. And compared with other years, March 2019 showed a very high chlorophyll concentration. And other found out was like we found that current is moving the bloom features in its direction with the bloom peak at the center of the ocean circulation features. Moving to the next parameter, SST, we use GHRST level for DMI, that is Danish Meteorological Institute datasets, which is having a 0.05 degree grid. So these are GHRST monthly analysis plots for 5 years, and it was SST was well depicted over the range of 22 to 30° for the study area we have chosen. And the variation of SST over months for these years was just the converse to the variation of chlorophyll. And compared with other years, high SST was observed for 2020 and low SST observed for 2018 and 19, which are the years which is having highest chlorophyll. So these are the mean monthly SST and mean monthly chlorophyll variation plots. And we can see that May and June, which is having mean monthly chlorophyll low value, is having highest SST. And from April to June, which is having very high SST due to solar radiation, the chlorophyll concentration is getting reduced over the ocean. Then during the southwest monsoon, chlorophyll values are again extremely high, where the SST is getting reduced. Then by October, like post-monsoon, these SSTs begin to raise. Then during northeast monsoon, the SST value again reduces till March, where the carbon concentration increases to the peak. Then by March, solar radiation again increases, which increases the SST value. Then the chlorophyll A concentration is decreasing over the ocean. This is the general trend followed throughout these 5 years. These are chlorophyll homolar plots from 18 to 22. One considered is at lowest latitude of study area, that is 90° north, and one is higher latitude of study area, 20° north, 23° north. And compared with the lowest latitude, alkaline plume presence was more found in higher latitude, and it is quite evident that the alkaline plume presence is mostly during the northeast monsoon period, that is from January to April. Then, if we observe the GHRSST over this year, it shows a very low value, so which can suggest that cooler SST are conducive to the proliferation of the alkaline plumes. So these are the chlorophyll annual analysis plot from 18 to 1922. So we can see chlorophyll or algal plume observed is high in 2018 compared with 22. So it can be directly shows that there is a subsequent reduction in the chlorophyll or algal plume from 18 to 22, and this high chlorophyll A may be due to the low SST during this 18. So this variation of chlorophyll from 18 to 22 was further decomposed or analyzed through a empirical orthogonal function. So it will extract the interannual variance of chlorophyll. So we found that A of 1 value as 67.11 degree, which indicates the dominant spatial pattern of chlorophyll in the data. That is the leading mode of variation. Again, A of 2 was 14.33, which is the second mode of variability. Also, we can see the PC components, that is principal components. So which will show the spatial variability of chlorophyll. So for PC1, it can be seen that it is increasing till 2021, then decreasing, and for PC2, it can be seen there is a gradual reduction from 18 to 19 itself. And these PCs associated with both modes are unimodal. That is they show one maximum and one minimum along a single year, but different phases. First mode has been maximum in November and its minimum in July, but second mode has maximum between August and October and its minimum in March. Next, we will move on to the monthly analysis of PFTs and PSCs from 2018 to 22. Before giving the analysis plot, I'll give a brief description of how these PFTs and PSCs has been retrieved. So in 2020, a study called titled as Global Chlorophyll Concentration of Phytoplankton Functional Types with Detailed Uncertainty Assessment using Multi-Sensor Ocean Color and SST satellite products. So these studies has presented an algorithm for properly retrieving this PFT from multi-sensor merged ocean color products and OLCA data using a empirical orthogonal function. So again in 2021, this study was reviewed. So this study was reviewed in such a way that it has incorporated SST into it. So this the modified name of this algorithm was EOF SST hybrid algorithm, and this is how we got different PFTs and PSCs, and this has been incorporated in the globe color chlorophyll data itself. So this shows the variation of diatoms, monthly variation of diatoms over these years, and for generally for all the phytoplanktons considered, it was dominantly bloom-burst features was observed in the range of 0.01 to 0.5 mg per meter cube. And if we consider diatoms, we can see that for surface monsoon, their dominance is high. And compared with other years, 2019 March shows dominant chlorophyll patches for diatoms. Then consider green algae. It was also shown similar patterns like diatoms. Also in northeast monsoon period, also we can see its presence. And distinct blue features were absent in April to June months if you are observing, which is having highest SST period. Next, cyanophyllates. There were also less dominant. If you observe that its presence is less dominant, and if it is showing something, it is during the period of southwest monsoon. This is haptophytes. You can see that during both monsoon period it is active in high chlorophyll ranges, mostly above 0.5 mg per meter cube, especially for 2018 September. This is microplankton, which is a phytoplant size classes. It is observed dominant during southwest monsoon period, and you can see that there is a reduction in airways from 2018 to 2022 for this particular phytoplankton. This is nanophytoplankton, which shows the similar trend of a microphytoplankton, and its dominant can be seen in both monsoon period, and throughout the month of February, this chlorophyll concentration is above 0.5 mg per meter cube, same like microphytoplankton. This is phytoplankton, which is observed to be the most dominant in the study area over these years considered, and in both monsoon period we can see the high chlorophyll concentration, especially in March, April and September. And compared with other years, 2019 April is having high algal bloom for these years considered. This is prochlorophytes, which is also dominant for showing prominent bloom features along the years considered, especially from January to September. We can if we closely observe, we can see that algal bloom starts in January and the growth is proceeding. Then it is declining by the month of October. Then algal bloom is reaching its peak by the month of March, especially for 19, 21 and 22 years. And the last phytoplankton considered was prokaryotes, and it is one of the dominant type after the phytoplankton, and its chlorophyll range was almost above 0.13 mg per meter cube. And except for April 2019 and March 2022, this chlorophyll concentration was almost below or equal to the range of 0.45 mg per meter cube. So next parameter considered was wind speed, and we have taken ELA5 monthly average wind speed data, and we utilized 10 meter wind speed and 10 meter UMB components. So these are the wind speed monthly analysis plot, which will directly validate the both monsoon periods. And we can see the southwest monsoon period, the wind speed is almost greater than the 10 meter per second. So next parameter considered was sea level anomaly. So we have taken it from Nova Costello's website of it's 0.25 degree grid. We used level 3 daily data and we have made into monthly composite and proceed with the analysis. And these are the sea level monthly analysis plots. And it was seen that it is most effectively ranged over the values like minus 16 to 40 centimeter. And there was an increment in SLI values were observed from 18 to 22. That is an increment by year wise. Then throughout 5 years, months of April, May and June observed high SLI. And if you observe monsoon seasons, which contribute to mostly to the algal bloom biomass, these are having very low SLI values, that is less than 27 centimeter. And during southwest monsoon, that is July to September, more negative SLI has been observed. So this is a correlation analysis plot done between the mean chlorophyll and sea level anomaly for the 5 years. So we can see a negative correlation coefficient value, which indicates there is a negative trend between chlorophyll and SLI, which will directly imply that the regions with elevated sea level anomalies, the condition for algal bloom must be less favorable. So from the study, we can link like that low SLI is linked with low SST, that which will give high nutrient and high chlorophyll, thus the algal bloom growth will be high. So the last parameter considered was photosynthetically available or active radiation. So these are the monthly analysis for the considered years, and it was well depicted over the range of 25 to 45 Einstein per meter square per day, and except for the monsoon period, our values was ranged above 45 Einstein per meter square per day, And if you observe, high par values are observed for months which is having low chlorophyll, which is a very intuitive fact. Then if we studies, like we will find like different algae species will be having different requirement of light. So for our study area, it was observed that species phytoplankton, prochlorophytes, and prokaryotes, they are having are showing dominant features when par values are high. And also we observed that for study area considered high par values are associated with high SLA values. So all these were the observations of our study. So let me conclude it with key inferences. So from the 5-year monthly analysis for the study area we considered, we found that most favorable condition for algal bloom growth in terms of ocean surface chlorophyll concentration, either it links with low SST, high wind speed, or low sea level anomaly, or low R conditions. Also, we observed that current is actually moving the bloom features in its direction, and the peak is found to be at the center of the ocean circulation features. And also we found the dominant type of phytoplankton observed for the study area was phytoplankton, then the prokaryotes. And from homolar plots we found that the high altitudes of the study area is having algal bloom with respect to when we are comparing with low altitudes. Also, in the studies, we came to know that there was an increment in SLA values over the years from 18 to 20. And these high SLA values are associated with high bar values. And except for monsoon period, these bar values are above 45 Einstein per meter square per day. And the algal species like phytoplankton, chlorophyll, prokaryotes, they are highly dominant over high bar ranges. These all were the inferences of our study. So, this study will definitely contribute to the future studies, especially which are associated with long-term trend analysis. So, I thank you everyone for this valuable time. Thank you so much.